So this is a presentation I did a couple weeks ago, and I'll run through some of the stuff that y'all seen before. But it was I gave it to the Research Reserves Science Cafe. Kind of gave them an overview of where we were, which was kind of fun. Had a good group there. So just to refresh everybody, we're doing the three sloughs. Douglas is about 27 miles upriver. Spiders is just off the Chipola, about 25 miles, and East River is at the top of the bay, about 14 miles from Apalachicola. Our team. So here's a picture of the Spiders Cut area, and the white area is the surveyed, actual surveyed Spiders Cut that we're going to be doing our work in. This is all land owned by FWC. This is the big floodplain that we're trying to bring more water down into. And then as it feeds south down through this floodplain, it reconnects into Howard's Creek and Brothers River and flows on to the Apalachicola this way. And this is about 1,500 acres of very, very dense swamp floodplain area. We'll talk about this briefly, but this little area right here is an abandoned clay pit that's on FWC's property, and we're looking at this as an area to take all of our spoil from the excavation and restore this sand pit, just kind of a side benefit of the project. So this is one of our key areas that we're looking at for restoration. So here's Spiders Cut. Little Spiders Cut is this piece over here. Spiders Cut is this main run right through here. This run over here is called Log Jam. Interestingly enough, Little Spiders Cut, for whatever reason, is pretty wide open, and so there's a lot of water running down through here. Spiders Cut is completely clogged up, as we talked about in our grant. And as we get back down into here, this is the end of our project down here at the south, and it's where it connects back up into the Little Spiders. So just by opening up this, we'll double the flow of water down into that region.
Ken, do you want to explain the color legend on that?
I will. I'll get to that. Just to give you a little history, this is way back when Dan and Matt Kondoff were looking at Spiders Cut. You can see how wide open the cut area is, but you can also see how clogged with sand. And down below, this is a recent photo after Hurricane Michael and the mess that we're having to deal with in the cut, and what we're going to have to deal with as we go into excavating that area. It was a much simpler project before Michael came into play. So here's the upper portion of the bay, or the of Spiders Cut. So this is a survey that's that we conducted. Scott Wall is an expert in this area. This is all tied to the local datum, or the national datum, and it's also tied to the datum down in the bay. So we're able to match all our data and these elevations up to Bluntstown or any of the other gauges or anything like that. We brought in GPS points to look at that. The interesting part here is here's the top of Spiders Cut, and some of you have been there, and you can see how clogged up the head of this system is. The purple is your deep water. So here's the Chipola River. The purple is the deep water. Right on the inside, we have a nice deep section. And then as we go farther down, and I'll show you, it gets really shallow. But this area right here, even in the deepest parts, there's probably 2 to 3 feet of material over what the flow elevation would be, around 5,000 CFS. And you can also see the limitation of the flow at anything above that. And so we'll be cutting out all of this triangular area in here down to about elevation 2. That will be the elevation of what the Chipola River would be if the Apalachicola was at 5,000 CFS. And that's kind of our goal. And that's based on the fact that technically the Corps is supposed to give the river 5,000 CFS all the time. And so that was kind of our starting point when we went through this exercise. All this island right in here, that's what you see right here. This is all willow trees that have volunteered onto this island and really stabilized this island in such a way that if this area is not cut out, it will completely enclose this, and then this slough will be abandoned forever from a floodplain contributor perspective. So this will give you an idea of what it kind of looks like. You can see all the material in through here. This is all sand. This is the water is just barely moving across the sand. So you're looking at this zone right through here. The blues and the greens are pretty well exposed most of the time. The blues are basically at the water level that we're seeing right now, which is probably about a +6 or 7 on the Bluntstown scale. And then as we get further down, it gets worse and worse through the system. All these targets right here are places we did vibrocores to look at the material. And these marks right here, the red spots, are where they did the mussel studies up and down the system. You can see how clogged up. These blues are really, really shallow areas. And here's a good picture showing just a little bit of a trickle of water going through there. We should be getting a lot more water, especially at the elevation that we're seeing right here. And this is all the way down at the bottom of the slough. This is about 5,000 a mile back in. And you can see there's no channel at all left. It just basically exists as part of the floodplain here. The water is high enough that you're getting a little bit of flow over top, but this is probably around 10 or 12,000 CFS. And this was done, this picture was taken about probably 2 months ago when we were down there doing surveys. And so I'll let you notice this cross-section AA right here. So this is our surveyed cross-section right through there. It'll give you an idea of what the elevations are. And this was one of our templates we put in to start to give us an idea of what kind of dredge profile we'll be looking at. This is about 4 to 5 feet deep. We're actually going with now in the final design, probably a little bit smaller bottom section. We want to make sure we stay well within the banks, that we don't interrupt, we don't impact any of the root systems of any of the trees that are along the banks. We also want to cut as little out as we can to make sure that we continue to get the velocity down the stream fast enough to keep it blown out in the future. A lot of times, if you open these up too much, the velocity of the water is too slow, the cross-section is too slow, and you don't, then you get a lot of material falling out. And so that's one of the things that we're trying to guard against. So we're talking about digging out about 4 cubic yards per foot over 5,000 feet. That's about 20,000 cubic yards, which it turns out, luckily for us at this point, that our guesses in the estimates in the original grant were pretty close to what we thought. And when you add on that big area at the head of the slough, we're probably about 22,000 cubic yards material we're going to try to remove out of here. And just to remind everybody, what we're doing this for is to rehydrate the floodplain. This is work from Helen Light in looking at the huge decline of swamp tree species back in the flood. Bringing the kind of water back through there that we're talking about is going to have a huge impact. We just got our about 2 months of water level data. We talked about it today at our monthly meeting with our team. Matt Deitch had looked at that water level data that we collected from upper and lower spiders, and we're seeing slopes between upper and lower spiders of 5 times what you see in the Apalachicola River. And that's an indication to us that once we open this up, it is going to accept a lot of flow because the hydraulic gradient, the slope of the water is going to be much greater coming off the Chipola and down into the swamp than it would be if it continued on down the Apalachicola River. And so that's just a really good sign for us that this is going to be successful in bringing a lot more water down through here during the low flow periods. Of course, if you remember, at high flows, everything goes over the bank and gets flooded anyway. So we're looking at the 5 to 15,000 CFS range for capturing flows through spiders. So on the East River project, this is a LiDAR picture. Our goal up there at the very top is to open up the East River section and to get more flow to the eastern portion of the distributaries, which will put more fresh water in Upper East Bay. That's what our goal, our objective is. All of these are the main discharge points, and we've been working with ABSI and the FSU FAMU folks to continue to quantify this whole area. More and more, we're getting them to recognize how important this piece of the bay system is to the freshwater delivery into East Bay. So it's been a good collaboration with those folks. So this will give you a little highlight of, this is the area up in here that we're talking about. That's about a 2.5 mile area that's completely clogged up from with sand from East River. And this will give you a perspective of where that is in the system itself. The system's hugely dynamic in our work in the system itself. Here's a place where on the Little St. Marks and the St. Marks where it's actually cut through. So this is changing all the hydraulics of the entire system just with this oxbow connecting these two rivers. This is just a great indication where we're actually seeing water come backwards and around, and actually coming from here around and feeding into into the St. Marks River. And eventually it'll cut this entire oxbow off altogether, and the flow will move down through here. This is a great example of how dynamic the system is and how important it is. This is also another area where we're getting a lot of flow through the old trestle, and one of the things that we want to look at is whether or not if continuing the berm through this area will keep water going down the East River and not allow it to be diverted this way into the St. Marks. Again, trying to push more water into the upper. So these are all the surveys from that we did for East River. This is about 2.5 miles worth. This is overlaid on the LiDAR, so wouldn't have been able to see this with the LiDAR, the NOAA LiDAR data. They can't penetrate trees, and so these are very high quality surveys. Here again, the purple are deeper areas and the blue are shallow. This area right through here is just above Graham's Creek, and there's a good indication that this area had been dredged to straighten out the system for logging. All of this in the LiDAR picture right here looks like it was spoil from where they dredged out parts of East River. And what I think is interesting is these lines right through here are probably the old cable lines that were drug out into the swamp and wrapped around the cypress trees and drug back to East River. And this section right here was an area that was cut out, was dredged to allow easier access into Graham Creek. Graham Creek runs up like this and around this way. And this was dredged through to make it easier to get there and take the logs up to those roads up by Bloody Bluff in that area in there and out to 65. So just some interesting history. Here again, this area is completely choked off. You do see some kind of maintenance of what you would consider a quasi-natural channel. The outside bends are still deeper. Side bends are fuller, but we're getting these blue areas like in here, a lot of really, really shallow areas that need to be cleaned out to be able to get the flow to run through here, through the whole, the range of low flows that we're talking about. Here's another indication of getting a good, this is the upper East River gauge. This is the lower East River gauge, 2.5 miles down. You can see it still has the tidal signal from 12 miles down to the bay, but we're getting a lot of flow coming. The steepness of the slope from the upper portion to the lower portion is significantly steeper than the Apalachicola flow. Therefore, water wants to flow in this direction. And once we open this up, we'll get a significant amount of flow going through this area. We did a lot of coring up and down through this whole system. Sand, and more sand. We found hardly any organics. We were in the 90 plus range in almost every core that we took. There's two issues related to that. One, because it's sand, it's going to be clean and we can deal with it really easily. And because there's not a lot of clay and silt, there's no, there's very little potential for contaminants. So we not a lot of having to deal with contaminated material here at all. It also tells us that this all probably came from the river itself. So, which is what we had hypothesized in the beginning. Yeah, Georgia?
Can I just interrupt there for a minute, Ken? Because some are familiar with this and some are not. So when you say it probably came from the river, well, how did it get in the sloughs then?
So a lot of the core operations, when they were doing dredging, what they would do is they would use within bank disposal areas. So they would dredge the material up and then they would stack it within the banks of the river. Part of that was because people got tired of them disposing it out into the floodplain and impacting the floodplain. The Corps had authorization and jurisdiction in the river, and so they would just pile it up in the river. And then they would wait for the high flows to come, and their theory was that when the high flows come, the velocities were higher, they could carry more sand down the river, and it would flush the system out. And that's true to a certain point. Then they got a little overconfident and they started stacking the sand so high that they were actually having to bring bulldozers in during high flow, and they were pushing the sand back into the river. And so you were having this huge influx of sand that was running down the system. And as soon as the velocity of the river slowed anywhere, that sand would fall out and it would clog the mouths of these, and it would run into these sloughs where the velocity was slower and would fall out into the sloughs. So just a lot of extra sand in the system that just created this condition that when it hit these sloughs where the flows were lower, they would just fall out, or if they got caught behind some vegetation and things like that. Okay. So here again, this is East River. The yellow is the deeper Thalweg. The Thalweg is the natural line that the river flows in. The blue line is the center line of the river. So the Thalweg is always wants to be deeper. Where the Thalweg and the center line come together are places where it's completely clogged up, and we'll be doing a lot of dredging. Where there's good separation, you'll be doing minimal to no dredging in those regions. And so with the level of mapping that we have, we can tag each of these areas and just dredge the areas that we need to. And a lot of that is just to make sure that you know, we're not interrupting habitat in these deeper zones that that already exist there. What we're really after is the clean sands and just opening up that channel. This line right here, this lower line, is basically what we're considering the deepest portion of the cut sections that we're doing. You can see it follows closely with the average slopes of the center line and the Thalweg line. And these are water level measurements that we took back in, I think these were in December, well, I guess February. So it'll give you an idea. This is pretty high water condition, but you can see the slopes on these areas pretty well match what we would expect to see in here. So that's all kind of fallen in line for it. So these are cross sections. So each one of these lines is 100-foot survey across East River. This is the bottom of where we want to dredge. So you can see where we got a lot of blue in here. It is pretty consistent across. We'll have a nice template that'll come down and take all this material out. In other places on the curves, you know, where we have some deep sections that are deep enough where we would expect that's where we want the flow to be in the first place. So in these areas, we're not going to do much dredging at all, and it'll maintain the natural shape of East River as we go down through. And this will give you an example of what a kind of a typical cross section would look like, and how we're just trying to take that little section out in the middle. And these were different test sections that we looked at to see what kind of volumes would be. So we're really after, you know, getting this little deep section right through here, and you know, it really will double or triple the area that's available for water to flow down through the East River system itself. Here again at the top of the East River, same kind of formation you saw in Spider's Cut. You know, the water is pushing sand down here. This is migrating. It's pretty well cut this whole section off. At some point, there'll be enough sand that this will close this completely, and it'll just totally isolate this. Well, you know, the most important areas to dredge are this piece right here and opening up this section right in here, just to open this throat up to get as much water as we possibly can. To a certain extent, we could do this and it would have a huge effect, even limiting some of the things that we're going to try to do downstream. I would think that just by doing this, we would improve it significantly. But doing the full dredging will get it done much faster. And this is just I think you've seen these pictures before, but this is what we anticipate the kind of the equipment that we'll be using if we do the project up at Spider's Cut. We won't need to use these geotechnical bags, but in East River we'll undoubtedly be using this kind of technique, whether it's on a barge. We have been talking to some beekeepers that have a lease on East River. If we can work out the timing, we'll be able to use some uplands that they use for putting their bees out at the right season to be able to put these big bags out. And we pump the water and the sand in here, and the water kind of oozes out. It kind of dries to a certain point, and then we can come in with trucks and haul this And we're talking with FWC right now with other potential restoration sites that we might be able to use this for, or this material will be perfectly fine for the Franklin County Road Department to use if they need it. And on the East River, you know, what we're really after is, and all the data we're collecting is to really look and to see if we can increase the water delivery into this section of Blunt's Bay and the Upper East Bays. So I think that's about it where we are right now. Any questions?